Good morning, everyone. Welcome to the call. This is the Affordable Hyper-Converged Solution call hosted by Boston. My name is John McCormick and I'm the UK BDM at Supermicro UK. The call today is going to be led by my technical manager of EMEA colleague, Steve Beck, and he's going to give you an overview and an introduction of the Supermicro ready-to-go hyper-converged appliance featuring Atlantis software. So I'd now like to hand over to Steve. Please do feel free to ask any questions through the call, through the question button on the right-hand side of the screen, and we'll get to the questions at the end of the call. Thank you.
Thanks, John. I'm hoping everyone can hear me at this point. Welcome, everyone. Thank you for attending this presentation. It's a presentation which is planned for about 30 minutes. I'm hoping to maybe just trim a couple of minutes off that, just to give some time for some questions through the question dialog box. I think it's fair to say there is a growing interest in hyper-converged solutions. Now, some may know what that is and some may not. And this presentation principally is aimed to highlight why there is this interest, and also to introduce a very compelling hyper-converged solution from Supermicro through our partner Boston. There's been a steady growth in the need to introduce more IT in a low footprint as possible with today's technologies. And Supermicro, being the first and foremost an engineering company, have been and are very well placed to address this. Our server solutions are typically first to market with innovation, be that the latest CPUs from Intel or the introduction of NVMe drives. We're very well positioned to deliver the highest levels of compute power in a smaller footprint and not at the expense of power and cooling. Now, this is important for hyper-converged architectures, and the solution I'll introduce you to will show how we make the very best of this leading hardware technology. So the agenda is a very brief agenda. I'll introduce a little history of storage. I've kind of been working with storage for about 30 years, so I can remember back in the days before we had even server-based storage. So that's a little interesting introduction. We'll talk about basic storage area network challenges, and then move on to, the main part of the presentation, is what is hyperconvergence, and particularly what is Supermicro's ready-to-go HCH-AC hyperconverged solutions. So back in the early 80s, this was the time when I was starting my IT career, we used to have very big centralized mainframe systems. I've taken the liberty to put what we call a UNIVAC system on there, and just showing my age, that system there, I used to work on as an engineer. Everything was centralized, including the storage. The compute power is everything you see on the left-hand side. So, that's taken up a great deal of floor space. And all the computing was done on this, and you would have people out in the offices would access that computer through the network, and applications would be run and results displayed. So what happened in the early 80s was a move away from those centralized systems to a more distributed distributed architecture, and this was principally driven by the emergence of the PC, the x86-based PC. So instead of having one big central resource of compute, you now have disparate little silos of compute based on each x86 server. Now, the problem with the storage problem, specifically with this kind of architecture, is that each one of those servers, which carried an operating system and carried applications, was served by its own internal storage. So there was a limit on that. The server enclosure can only handle so many drives, and if you wanted more storage, you had to buy another server. And this kind of led to what is termed server sprawl. Physical server sprawl. And in some of the big banks, for instance, you would have hundreds, if not thousands, of these servers, which posed its own problem. One was the management challenge, maintaining each and every one of these servers, backing up each and every individual server, and also the space as well. hundreds of servers and taken up lots of space. But from a storage perspective, this was a non-shared storage resource across the servers, meaning that server A could not access the storage which may be available on server B. So the utilization of the whole storage estate was very poor. So in the mid-90s, what happened was there was an introduction of what they called a storage area network, and principally what this is a centralized storage platform or repository, which you see at the bottom of the diagram, and then through a special network of switches and directors, principally designed for specific storage protocols, is you have the servers and the applications accessing that. Now this made things easier, principally because now you could share resources. So server A could actually, wasn't limited by its internal storage capabilities. It had access to as much storage service as what could be offered up from that central resource. It offered centralized storage administration, which meant that all the backups could be run from the same storage space. And it just made life a lot easier. It was a step in the right direction. But remember, this was back in the mid-90s. This was a long time ago. There was a move a little later after that. Instead of having physical servers connected into that storage area network, with the introduction of things like VMware, or VMware, wasn't vSphere in those days, but VMware, you now turned a lot of those physical servers into virtual servers. But again, it's very easy to get into this sprawl type scenario with VMware because you can create a new virtual machine pretty quickly. And so you've now got some different management challenges introduced into the storage area network. So today's basic storage area network problem is based on three distinct levels, one of which is at the server level or the host server level, management and cost. The second is at the network level, and the third is actually in the storage level. So storage area networks have been around a long time. So now we're in the 2000s. There is a new way of perhaps addressing this centralized resource for storage, and this is what we call a hyper-converged architecture, which is the SAN alternative. So it's to simplify IT. It's just another evolutionary step to simplifying IT, and specifically to simplify the resource provisioning of storage. It makes management more efficient. You've got seamless scalability. It improves the agility of the company and the dynamics of the company, and also drives down the cost. So you consider all of this storage area network stuff to be collapsed into something far, far more manageable and far simpler. And this is what I would term SAN in a box, which is a scale-out storage architecture, and I'll cover that as we move through the slides. So a very simple hyperconvergence is something that is called vSAN. You may have come across this terminology. It is a hyperconverged infrastructure, and it consolidates all of those SAN elements into hardware, which is commodity x86 building blocks. So it creates a virtual SAN for the application virtual machines, and there is no SAN external network. You do need a hypervisor like VMware for these kind of hyperconvergence. No matter who offers hyperconvergence, it has to have a hypervisor of sorts. And because vSAN is a VMware product, VMware offering, it's all built around their VMware vSphere software with some storage smarts The storage smarts is the intelligence to connect your virtual machines and their requirements through to the storage, which sits on a cluster of x86 servers with internal drives. Now, taking hyperconvergence to the next level is we move to our ready-to-go solutions. So, going back to the point of our, industry-leading technology in getting more compute power in the smallest amount of space as possible, this solution, this hyperconverged solution, is based on our industry-leading Twin Pro technology. So these are 4 compute nodes with fully redundant, highly efficient power supplies, redundant fans, and also you have 2.5-inch SSDs, which are incorporated into that architecture. The solution can either feature VMware as the hypervisor, or you can feature Zen Server. That's the end user's preference. And then onto that is loaded the storage smarts, the software intelligence from our partner company called Atlantis. And what that delivers is a hyperconverged solution, which is resilient, with resiliency across the nodes. If a node fails, then the system continues to run. And available and effective, and I'll close down on that word effective as we move on, but in effective capacities of 12 terabytes or 24 terabytes today, with 48 terabytes on the way, and other developments around other hardware platforms as well. But that's, let's say, short-term futures. I won't talk about those things today, but gradually, as the initiative, the business develops, these new platforms will come into the fore. So this is a very, very cost-effective solution which sells against companies who are doing extremely well out there, it has to be said. Nutanix, SimpliVity, EvoRail, not so well for lots of reasons, one of which is the price tag, but the other guys are expensive as well, Nutanix and SimpliVity. These solutions come with the standard next business day warranty, 3 years. So where the software sits, it actually sits in one of those hypervisor virtual machines, and all the storage resourcing for all of the other virtual machines is routed through that Atlantis intelligence. So the storage capacity is in the smaller unit, which is the AC12, which is 12 terabytes effective capacity. There are a total of 12 400 gigabyte SSDs, Intel SSDs. And the base RAM for that model is 256 gigabytes. Now, there is an option to upgrade that DRAM capacity in chunks of 128 gigabytes, but this has to be specified at time of order. It cannot be retrofitted in the field. That option isn't there. On the 24, all that's happened really is that the drives have just doubled in capacity, so it's the same count of drives, 12, but there is a base entry level point of 512 gigabytes of DRAM, which again can be upgraded by an increment of 128 gigabyte steps, but only at time of order, really. Now, each of those compute nodes has an internal SATA DOM, and each would boot from their own internal SATA DOM. It's a very simple architecture, and very compact. So this is a scale-out solution, and what that means is that the 4 compute nodes actually work as one entity. They work as a cohesive cluster. So any one of those nodes has access to any other node's storage capacity. In fact, when this is configured, all of the storage is collected in pools, and those pools can be accessed from any one of the nodes. There is some very clever technology at play here from Atlantis, which is over and above what you will get from the other guys, including vSAN and SimpliVity and Nutanix. It's very well suited to very high demanding workloads, and the way that it actually gives you that performance is some very clever capabilities around deduplication and compression. So the fastest place to affect deduplication and compression, and it can be introduced at different layers of the stack between compute and storage, is actually to run the deduplication and the compression in DRAM itself, and this is exactly what Atlantis does. This is where Atlantis have spent all of their research and development money to make themselves different. And their understanding right at the beginning of their development venture was, how can we make things more efficient? How can we break the connection, coupling between high IOPS, that's input-output transaction count, and its relationship to back-end storage. So typically, without this kind of approach, if you want more IOPS, you would have to introduce more disks, and they could be more SSD, or they can be more spinning disk, but you needed more to get more IOPS. So what Atlantis have done is they've said, well, how can we cut down the time it takes to move data around? They say, well, before we start moving it anywhere, what we can do is we can deduplicate it in DRAM, which is the fastest place to do it, of course. And then before we move any of that data down to the SSDs, is we will further compress it as well to save space. But with less data moving around, you're getting a performance increase. Also, the technology caches the data. So if the data is hot, i.e. the application has a real interest in that data and actively using it, it will remain in DRAM. So this also speeds up the performance. It sounds like an easy thing to do, but it isn't. And this is why, you know, with the focus from Atlantis on doing this exceptionally well, the result is an exceptional solution. So if the data is cold and is down on the SSDs, as soon as the application has a renewed interest in it, it's uncompressed and moved back up into DRAM. So the performance tier, you can call it, is actually in DRAM, and the capacity tier is on flash. So it's feature rich. There are some features that it must have to be able to be competitive. High performance is one of those, and I'll explain the way that it does that. But thin provisioning and snapshots is a way of saving space, but it's also a way of being able to provision your point-in-time copies of data that perhaps needs to be backed up. There is a feature in there which is called fast cloning. So this means that if you've got a volume that you need to do, which contains data, you can create more or less an instantaneous copy of that volume, which can be mounted, and then some development work can take place against that real data, totally separate from the performance data, which is on the original volume. There is a data mobility feature which will allow these clusters to talk to each other over a geography and to be able to ship data between sites. Now, in fairness, this isn't a synchronous copy, which is usually an enterprise called-for feature, but that is on the way. I hear tell from my friends at Atlantis is that this is due for release at when we move into the last quarter of this fiscal. I've explained that it's cluster-wide data protections. And the way that it spreads the data across the pool, across those drives, is in a way that removes what is typically termed a RAID overhead. Now, it isn't a RAIDed system. It's more closely associated with something like an object store. So you do not suffer the performance penalty of writing to data which is on a RAID set of a number of drives. Because the penalty there is that before you can do the write, you have to read the data, you have to overwrite it, you have to recalculate the parity, and then write that back down onto the media. The scalability is proven to 256 nodes, and they haven't gone beyond that. That's a difficulty in, you know, the amount of hardware you can actually make available at any one time to see how far this will scale out. But 256 nodes, I can't see anyone at the moment who's going to need 256 nodes, but it's a nice comforting feeling that this thing will scale out as far, particularly as you would want. So why would your customers want it? Well, you know, it's simple. It's simple to understand. It's a simple alternative to a costly SAN if they're running those. It breaks this cost per IOP, cost per storage coupling. So if they've got a high IOP demanding database, for instance, a big transactional database, and they want that to run as fast as possible, then you know they can use this as the alternative as opposed to throwing more and more disks or even introducing SSDs into an existing SAN. It's single pane of glass management. There is an interface very closely with vSphere or Zen servers management software. Self-tuning, built-in fault tolerance. What that means is that if you lose one of these 4 nodes, if it's a 4-node cluster, in fact, what happens is that your architecture is built on 3 nodes. And the 4th node is like the hot standby. So it will run on 2 of those 3 nodes. But the 4th node then is there to allow the remaining 2 nodes to rebuild the 3rd node. So now you're back up and running on 3 nodes, everything's good, and then the failed 4th node, the original of the 3, can be replaced. And then that then becomes the standby. When that replacement node is introduced, Atlantis will spread the data across the drives within that new node. So this is a lower storage capex. The price points are very aggressive, and a low OPEX. There's no specialized skills needed here. It's easier to manage. And it's budget friendly. It's ideal for SMB and SME. As I mentioned before, it doesn't have a particular synchronous copy feature, which is called for by the enterprise. So by the end of this year, we're going to be in a position where we can offer this in as a replacement to a SAN, which could be, you know, one of the major players, EMC, Hitachi, NetApp, that kind of stuff. Typical use cases, well, I've touched on a few, but one of the ones which kind of gets missed, and I've put this right at the top, is there are still quite a lot of end users out there who are still running disparate servers. So if you just throw your mind back to that, you know, that distributed architecture with separate servers, they're still running that way. And some of them with servers, a small environment might have 4 servers, a larger one may have a dozen servers. And you know, my past experience has been that you know, these guys have looked at virtualization for the server level to introduce VMware or Zen Server. And without hyper-converged knowledge, they've looked at the cost of a storage area network and thought, you know, this is too expensive. So just to move to storage for server virtualization, the cost of the supporting centralized storage area network has been too much. And so they've shied away from it, they've stepped back. But now I think there's a great opportunity to actually revisit those people and say, look, you know, there is a simpler and more, you know, cost-effective way to do it. And by looking at hyper-converged, and specifically this solution from ourselves, then this could be a viable project now for them. Because of the packing density of our hardware, you're now looking to consolidate servers in the data center. I know a few customers who are looking at this particular technology to actually save space and save power. There may be a new tier 1 application which has a very high demand for IOPS. And there may be a reluctance to actually put that on an existing SAN, production SAN, because it could drain a lot of the performance from that SAN. They could be looking at increasing at cost the capabilities of that SAN to accept that high demand workload of that new application. So the argument here is, well, why don't you run this particular high-demand application on a separate low-cost infrastructure, which is the hyper-converged infrastructure. High-performance test and development, because of its low price point, this again is an opportunity for people who want to run high-performance test and development to actually make a smaller investment in this architecture than actually buying kind of like a mirror image of their existing SAN. So once it's gone through its development, once it's gone through its performance, then, you know, then they would typically port that over into their existing production SAN with all the challenges that that presents. Simple remote SAN alternative, that's kind of touching on the first bullet point as well. That you can remotely manage this quite simply through a GUI. To a browser, I beg your pardon. So, you know, there are alternatives to having a small SAN with the switches and the storage and the servers out in remote offices. The real sweet spot for this technology is deploying VDI. So the appetite for VDI is actually going up. Atlantis themselves have some really, really powerful use cases in this environment. I think JP Morgan have got something like 100,000 plus virtual desktops running on Atlantis technology. Colt Telecom upwards of 15,000. This really does the job in the VDI space. Now, you know, what's killed early adventurers into VDI projects is again the cost of the supported storage. With people looking at things like pure storage or violin memory, these are all flash, high cost storage footprints to actually address the high IOP demand of VDI. Well, they don't need to do that anymore. With this hyper-converged solution, which has the performance that you need, fully proven in the VDI space by Atlantis, this is an absolute sweet product for that space. Anything which is underpinned by a database, so this could be very large exchange environments with a lot of dynamics associated with that, or stood-alone Oracle SQL type databases which have a, you know, high transactional demand. So that could be the back end of a web-based business. Web-based business needs low latency. It needs a user experience out there on the web, whereby they make an inquiry into the back-end database and they want the results back quick. And if they don't, then they'll move on somewhere else. They don't want to be waiting an age for the result. So for high transactional database just underpinning web-based web-based business, I mean, this is also a very good place to look to sell. The surface specifications, I've touched on these. I've explained where we get the effective capacity from with the deduplication and the compression. But the numbers below there, the general purpose server virtual machine, so with that server virtual machine profile of 2 virtual CPUs, 4 GB of RAM, 60 GB of disk space, then we're looking at the smaller of these units to be able to support somewhere around about 174 of those virtual machines, which is quite impressive. And the larger one, nearly 370. The virtual desktop environment, and these are all real numbers, these are proven numbers, if this was all task workers, and they were stateless VDIs, which need just a little less engine power than a persistent VDI instance. On the smaller of the units, you're looking at being able to support 450 task workers, with the larger model being able to address 650. And as you move across the slide through knowledge worker and power users, these guys are placing more of a demand on the system, so those numbers come down. I've given some, I don't talk pricing per se, but I think it's of interest to you guys to see what we're talking about here when we're talking about a lower cost alternative to the things which are out there today, which are doing particularly well, but they don't fit all environments, and especially the SMB, SME. So I've got a pretty good idea of the street price, but I'm not going to post it for Nutanix. But compared to us, we're looking at these kind of numbers. And you'll notice that that Nutanix box is a hybrid capacity. So this isn't all flash. It is a mix between spinning disks and flash. On a slightly different box, we have the big, compared to the bigger of ours, you're looking at 50% less capacity, 4 times more expensive cost per gigabyte. So these are compelling arguments, especially for the SMB, to seriously look at hyper-converged, and especially if they've been looking at Nutanix and been fired up by it, but then looking at the cost and thinking, whoa, that's way out of our league, we're not going to go there. EvoRail. EvoRail is very expensive in comparison, and it's also, EvoRail is pretty much vSAN with some cleverness built around it for real dynamic environments. The EvoRail is only really going to sell into the big enterprises who've got moves, adds, and changes going on all the time. And this is particularly why EvoRail isn't doing particularly well at the moment. But comparing our solution to this, then you can see, pretty dramatically that there's an advantage in the ready-to-go solution from ourselves through Boston. So my last slide really is why Supermicro for software-defined storage. Now, software-defined storage is the concept, as I've kind of covered here, is a piece of commodity hardware, our Twin Pro, introduce some storage intelligence, Atlantis, and that is a software-defined storage solution. Now, because Supermicro have more hardware options, we get closer to the optimum hardware required for an SDF solution. It's fair to say that the other guys are also, the HP, Lenovo, Dell, they all sell their own software-defined storage solutions, but they also sell a lot of their own storage. They've made big investments in companies like FreePar, Ecologic, Compellent. They've all got their own major investments in these companies. So from a business perspective for these guys, this is their real focus, is selling that and get a return for the investment they made. Now, you know, this is my view, not necessarily Supermicro's, but my own professional view is that they have joined the SDS storage solutions marketplace to edge their bets. They want to be able to offer software-defined solutions, otherwise they'll miss out. But that causes problems for them internally because you've now got two distinct areas. You've got one area which is selling their own stuff, which is going to make them lots of money, and the software-defined solution, which isn't necessarily going to make them a lot of money. So there is a little bit of a conflict of interest, and I believe that the sales team compete internally within those organizations, which can lead to protractions when they engage with their resellers. So the appetite for Supermicro generally across all of our product range continues to grow. I'm seeing this. I've been with Supermicro for 5 months, and I'm seeing this just in those 5 months. We've now got discussions with some fairly sizable outfits who are wanting to look at a serious alternative to the usual list of suspects, HP, Lenovo, Dell. And again, a lot of those discussions around the total cost of ownership and trying to drive the ownership costs down. So guys, that kind of like concludes the presentation. I'm probably 5 minutes over. I apologize for that. If there are any questions, then I'd be quite happy to answer any. John, back to you.
Hi Steve, thanks for that great overview. I hope the audience can see that this offers a really disruptive solution for a whole variety of projects, and certainly to go after the larger resellers offering the more traditional or expensive competitive hyper-converged solutions. So I do urge you to go and get a quote from your Boston account manager to see really how competitive we are. I sent a link out a moment ago so that you can register to actually try this kit for yourself. So you can go to Boston and have a dedicated session on one of the appliances, so you can see how this performs, play around with provisioning some VMs, just have a good understanding of the Atlantis software that's on there, and Boston can arrange that for you. So please do see the link that I sent around in chat a moment ago. There was only one question, Steve, that came through during the presentation, so I think you covered most of the questions people have. But that question was asking which actual SSDs are used in the AC12 and 24. I believe that to be Intel branded SSDs.
They are indeed, yeah.
Yeah, and the sizes we obviously disclosed as 400 gig and 800 gig in size, depending on which option of box you go for.
So that's correct.
So I'm just looking to see if there are any more. Not quite sure I understand the question. Enterprise SSD is just a comment that was made. Not sure what that means. Maybe Mal, if you'd like to clarify that. Certainly, if you've got any more detailed questions around the technology or the hardware or how to use Atlantis, you can contact Steve and myself through your Boston account manager. The question: are the SSDs enterprise class? Indeed, they are.
Indeed, they are enterprise class. One of the things I didn't mention about SSDs, which is you know, for any of the audience who know a little about SSDs and some of the challenges that's associated with it, is that unlike a disk, you cannot overwrite data on an SSD. You have to erase it first, and then you have to write your data on there. And this is over a period of time, this is recognized as a bit of a challenge because you can wear out the SSD, for want of a better phrase. So there are some techniques which SSDs use, which is called wear leveling, to kind of reduce the impact of this. But where Atlantis kind of bring a little bit of value to this is that when it's going to write down to the SSDs, it doesn't write the data straight away. It pauses it, it coalesces it, is the technical term. And then only when it's decided that it really does need to be written down to the SSDs, it will do that. So what this means is that it reduces the write impact, the amount of write that needs to be done to the SSD, and it extends the life of that SSD. But yes, they are enterprise SSDs.
Thanks, Steve. Another comment that came in is early burn covered by warranty. I don't know if that's something you could answer also.
Early burn?
Again, relating to the SSDs.
Oh, well, the 3-year net business day warranty covers it all, right? So, you know, your support is a single point of contact. So a 24/7 point of contact would be through principally through the Atlantis call desk, and they would determine whether or not it's an Atlantis issue or a hardware issue. And if it's a hardware issue, then they pass it to Supermicro.
Yeah, and that's a good point to revisit as well, Steve, that the 3-year warranty and support is all covered as part of the cost of this product. And as you say, Atlantis are the front line, so for maybe smaller resellers that don't have huge support resources available to them, they can relax knowing that the solution they've sold, the first point of call could well just be off to Atlantis, and that would take a big support burden away from them. So I think that covers all the questions, Steve. I don't see any more coming through now. So thanks again, guys, for attending and dialing into the call. And thanks also to Boston for arranging this. Please do click on the link to register your interest to physically try out the appliance and see how this performs and operates. But if there's any questions at all, please reach us through your Boston account manager. Thank you very much.